The National Electrical Code, or NEC, mandates that all swimming pools undergo bonding. This bonding establishes a pathway for fault currents, enabling them to safely return to the ground, thereby mitigating the risk of electrical shock. Specifically for fiberglass pools, even though they typically lack metal components, bonding remains a crucial requirement. The entire pool structure, including any fiberglass ladders and handrails, must be integrated into the electrical system through bonding. The code inspector's guidance to bond the pool light to the pump motor and then to the main service panel ground rod is indeed correct. This stems from the fact that the light fixture presents a potential electrical hazard within the pool vicinity. Bonding light fixtures made of fiberglass presents a unique set of challenges. However, bonding is still achievable even when the shell consists of non-conductive materials. Employ a conductive adhesive. Apply a conductive adhesive, like copper tape or epoxy, to the interior surface of the light fixture. Subsequently, attach a bonding wire to the applied conductive adhesive. This wire should then be routed through the conduit leading to the junction box located at the pump motor. The bonding wire originating from the light fixture should be securely connected to the ground terminal found on the pump motor. Following this connection, a separate bonding wire should extend from the motor's ground terminal to the ground rod positioned at the main service panel. While bonding might appear redundant for a fiberglass pool, it remains a pivotal safety measure in safeguarding individuals from electrical shock. Adhering to the code requirements for bonding guarantees a pool installation that is both safe and compliant. In conclusion, the code inspector's directives align with the NEC guidelines. Although bonding a fiberglass light fixture might necessitate some ingenuity, it's not only feasible but also indispensable for ensuring proper electrical safety for the pool environment. Diving deeper into the technical aspects of bonding fiberglass pools, let's explore the specific requirements and best practices to ensure a safe and compliant installation. Firstly, understanding the purpose of bonding is crucial. Bonding creates an equipotential plane around the pool, meaning all conductive surfaces are at the same electrical potential. This minimizes the risk of electric shock by preventing voltage differences that could cause current to flow through a person in the water or around the pool. Secondly, let's address the materials and tools needed for bonding a fiberglass pool light fixture. You'll need the following items. 1. A conductive adhesive such as copper tape or epoxy specifically designed for electrical bonding. 2. A bonding wire of appropriate gauge, typically number 8 solid copper, but consult local codes for specific requirements. 3. A suitable connector for attaching the bonding wire to the conductive adhesive, ensuring a secure and corrosion-resistant connection. 4. Tools for cleaning and preparing the surface of the light fixture to ensure proper adhesion of the conductive material. And 5. A conduit to protect the bonding wire as it runs from the light fixture to the pump motor junction box. Thirdly, the process of bonding the fiberglass light fixture involves several key steps. Step 1. Thoroughly clean the inside surface of the light fixture where the conductive adhesive will be applied. Remove any dirt, grease, or coatings that could interfere with adhesion. Step 2. Apply the conductive adhesive evenly to the clean surface. Ensure that the adhesive makes good contact with the fiberglass material. Step 3. Attach the bonding wire to the conductive adhesive using a suitable connector. Make sure the connection is tight and secure to provide a reliable electrical path. Step 4. Run the bonding wire through the conduit to the pump motor junction box. The conduit protects the wire from physical damage and environmental factors. Step 5. Connect the bonding wire to the ground terminal and the pump motor. This connection must be secure and corrosion resistant. Fourthly, the connection from the pump motor to the main service panel ground rod is equally important. This connection ensures that the entire bonding system is properly grounded. Typically, a number 8 solid copper wire is used for this purpose, but again, consult local codes for specific requirements. The wire should be run in a conduit or buried at a depth specified by the NEC. Fifthly, when connecting the bonding wire to the ground rod at the main service panel, use a listed connector designed for direct burial. This connector must be corrosion resistant and provide a secure electrical connection. The ground rod itself should be driven into the ground to a depth specified by the NEC, typically 8 feet. Sixthly, it's important to understand the role of the equipment grounding conductor, or EG, in the overall grounding and bonding system. The EGC is the wire that runs from the circuit breaker panel to the electrical equipment, such as the pool pump motor. It provides a path for fault currents to return to the source, tripping the circuit breaker and energizing the circuit. The bonding system and the EGC work together to provide a comprehensive safety system. Seventhly, let's discuss some common mistakes to avoid when bonding a fiberglass pool. One common mistake is using the wrong type of conductive adhesive. Not all adhesives are suitable for electrical bonding. Make sure to use products specifically designed for this purpose. Another mistake is failing to properly clean the surface of the light fixture before applying the adhesive. This can result in poor adhesion and unreliable electrical connection. Another common mistake is using the wrong size or type of bonding wire. The bonding wire must be of the appropriate gauge and material to carry fault currents safely. Eighthly, the NEC provides specific guidelines for the size and type of bonding conductors. Table 250.122 provides guidance on the minimum size of equipment grounding conductors for grounding raceway and equipment. Table 250.66 provides guidance on grounding electrode conductor size for alternating current systems. These tables should be consulted to ensure compliance with the NEC. Ninthly, consider the specific requirements for underwater lighting fixtures. Section 680.23 of the NEC covers the requirements for underwater luminaires, or lighting fixtures, and their installation. This section includes specific requirements for bonding, grounding, and wiring methods. It's important to carefully review this section to ensure compliance. Tenthly, regular inspections and maintenance of the bonding system are essential to ensure its continued effectiveness. Check the bonding connections for corrosion or damage. Ensure that the bonding wires are securely connected and that the ground rod is in good condition. If any problems are found, they should be corrected immediately. 11thly, the importance of documentation should be emphasized. Keep detailed records of the bonding installation, including the materials used, the methods employed, and the results of any testing. This documentation can be helpful for future maintenance and inspections. 12thly, the role of the local electrical inspector should be highlighted. The electrical inspector is responsible for ensuring that the installation complies with the NEC and local codes. It's important to work closely with the inspector throughout the project to ensure that all requirements are met. 13thly, remember that the NEC is a minimum standard. It's always a good idea to go above and beyond the minimum requirements to provide an extra margin of safety. For example, you might consider using a larger gauge bonding wire or installing additional ground rods. 14thly, continuous education and training are crucial for staying up to date on the latest NEC requirements and best practices. Attend industry seminars, read trade publications, and participate in online forums to expand your knowledge and skills. 15thly, the use of ground fault circuit interrupters or GFCIs is another important safety measure for swimming pools. GFCIs are designed to detect small ground faults and quickly de-energize the circuit, preventing electric shock. The NEC requires GFCIs for receptacles and circuits serving swimming pools. 16thly, consider the specific challenges of bonding a pool with a saltwater chlorination system. Salt water can be corrosive to metal components, so it's important to use corrosion-resistant materials and connectors in the bonding system. Additionally, the salt water itself can create a conductive path, so it's even more important to ensure that all conductive surfaces are properly bonded. 17thly, be aware of the potential for stray voltage in the area around the pool. Stray voltage can be caused by nearby power lines, underground cables, or other electrical sources. It's important to test for stray voltage and take steps to mitigate it if necessary. 18thly, the importance of proper grounding and bonding cannot be overstated. These measures are essential for protecting people from electric shock and preventing electrical hazards. By following the NEC requirements and best practices, you can ensure that the pool is installed in a safe and compliant manner. 19thly, remember to always disconnect power before working on any electrical equipment. This is a basic safety precaution that can prevent serious injury or death. Use a voltage tester to verify that the power is off before touching any wires or connections. 20thly, if you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Electricity can be dangerous, and it's important to have the work done by someone who is trained and experienced. 21st, when selecting an electrician, make sure they are licensed and insured. Ask for references and check their qualifications. A qualified electrician will be familiar with the NEC requirements for swimming pools and will be able to ensure that the installation is safe and compliant. 22nd, the NEC is updated every 3 years, so it's important to stay up to date on the latest changes. The NEC is a complex document, and it can be difficult to understand all of the requirements. Consider taking a course or attending a seminar to learn more about the NEC and how it applies to swimming pools. 23rd, always consult with a local building department or electrical inspector before starting any electrical work. They can provide guidance on local codes and requirements. They can also inspect the work to ensure that it is done properly. 24th, the bonding system should be inspected annually by a qualified electrician. The inspection should include a visual inspection of the bonding connections, a test of the ground resistance, and a check of the GFCI devices. 25th, keep a record of all inspections and maintenance performed on the bonding system. This record should include the date of the inspection, the name of the electrician, and any problems found. 26. The bonding system is an important part of the overall safety system for the swimming pool. By following the NEC requirements and best practices, you can ensure that the pool is safe and compliant. 27th. It is essential to understand that simply because a pool is constructed of fiberglass, which is a non-conductive material, does not exempt it from the NEC bonding requirement. The purpose of bonding is not solely to address conductive materials within the pool structure itself, but to create an equipotential plane in the pool area. This equipotential plane minimizes the risk of electrical shock by ensuring that all metallic objects and conductive surfaces in and around the pool are at the same electrical potential. This prevents dangerous voltage differences that could lead to electric shock if a person comes into contact with two surfaces at different potentials. 28th, the requirement to bond the pool light, even if it has a fiberglass forming shell, is based on the potential for electrical faults within the light fixture itself. Even with a non-conductive shell, there are still electrical components inside the light fixture that could develop a fault and energize the surrounding water. Bonding the light fixture provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit, thereby preventing electric shock. 29th, the NEC also requires bonding of other metallic components in and around the pool, such as the pool pump motor, metal ladders, handrails, and diving boards. This is to ensure that all these metallic objects are at the same electrical potential, further reducing the risk of electric shock. 30th, the inspector's insistence on bonding back to the main service ground rod is also in line with the NEC requirements. This is because the main service ground rod provides a connection to the earth, which helps to stabilize the electrical potential of the entire system and provide a path for fault current to flow back to the source. 31st, using a separate ground rod near the pool pump is not an acceptable alternative to bonding back to the main service ground rod. This is because a separate ground rod may not provide a sufficiently lower impedance path for fault current, and it may not be effectively connected to the rest of the electrical system. 32nd, bonding is a critical safety measure that helps to protect people from electric shock. It is essential to follow the NEC requirements and best practices to ensure that the pool is installed in a safe and compliant manner. 33rd, remember that electrical codes and regulations can vary depending on your location. Always check with your local building department or electrical inspector to ensure that you are following the correct requirements for your area. 34th, do not hesitate to ask for help from a qualified electrician or electrical inspector if you have any questions or concerns about bonding your fiberglass pool. They can provide valuable guidance and ensure that the installation is done safely and correctly. 35th, In the context of the NEC, the term bonding refers to the permanent joining of metallic parts to form an electrically conductive path that will assure electrical continuity and the capacity to conduct safely any current likely to be imposed. This is distinct from grounding, which refers to connecting electrical equipment to the earth. While both bonding and grounding are important for electrical safety, they serve different purposes. 36. The bonding conductor, typically a number 8 solid copper wire, must be installed in a manner that provides a continuous and reliable electrical connection. This means that the wire must be securely connected to all metallic parts and must not be interrupted by any non-conductive materials. 37. The bonding connections must be made using listed connectors that are suitable for the application. These connectors must be corrosion resistant and must provide a secure electrical connection. 38. The bonding conductor must be protected from physical damage. This can be accomplished by running the wire in a conduit or by burying it at a depth specified by the NEC. 39. The bonding system should be tested after installation to ensure that it is functioning properly. This can be done using a bonding meter, which measures the resistance of the bonding connections. 40th. The resistance of the bonding connections should be as low as possible, ideally less than 1 ohm. A high resistance indicates a poor connection, which could compromise the effectiveness of the bonding system. 41st. If the resistance of the bonding connections is too high, the connection should be cleaned and tightened. If this does not resolve the problem, the connectors may need to be replaced. 42nd. The bonding system should be inspected regularly to ensure that it is in good condition. This inspection should include a visual inspection of the bonding connections, a test of the ground resistance, and a check of the GFCI devices. 43rd. Any problems found during the inspection should be corrected immediately. This may involve cleaning and tightening the bonding connections, replacing damaged connectors, or repairing the bonding conductor. 44th. The bonding system is an essential part of the overall safety system for the swimming pool. By following the NEC requirements and best practices, you can ensure that the pool is safe and compliant. 45th. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about bonding your fiberglass pool. They can provide valuable guidance and ensure that the installation is done safely and correctly.